All right, welcome back. This is going to be the homework for functions. Let's go ahead and start it. For the function f, the table above shows some values of x in their corresponding values of f of x in terms of the constants a, b, and c. So this is x, this is y in terms of a, b, and c. Okay. If a is less than b, which is less than c, which of the following could not be the graph of y equals f of x? So we know that a is going to be less than b and b is going to be less than c. So a is the lowest one of all. So at x equals 1, so if we have a graph, all right, at 1, which is right here, we know that a is going to be like below b and c. We know that. So at 2, this is going to be b right here. And at 3, this is going to be c. So like we know that a is less than b, which is less than c. So we know the trend is going to be like this. We don't know how much bigger or how much smaller each number is, but we know that it's going to follow this trend. So a follows this trend. So a at 1 is less than b at 2, which is less than c at x equals 3. We can see that this one follows this trend as well. That's a, that's b at 2, at x equals 2, and that's c at x equals 3. This one also follows the trend. That's a at x equals 1, that's b at x equals 2, and that's c at x equals 3. And so b is the only one that cannot be it. Okay? Looks like a hard problem. Not really. It's just interpretation. 2. For the function f defined above, what is the value of f of 1? That means what's the value of y when x equals 1? So value of y when x equals 1. That's what f of 1 means. So f of 1, we can just substitute x as 1 on the equation. 2 times 1 minus 1 plus 2. So this is going to become 1. 2 times 1 minus 1 is 0 plus 2. So that's equal to 0 plus 2. That's equal to 2. So B is right. F of 1 equals 2. And that's coordinate 1, 2, because when x is 1, y equals 2. Okay, we've done this on the intensive if you guys have taken classes with me. So the graph of the cubic function f is shown in the xy plane. If f of a equals 0, so when x equals a, y equals 0, where a is a constant, what is one possible value of a? So we know that when a equals something, y equals 0. So when does y equal 0? Right here in this line. Okay, that was bad. This line right here. So here, here, and here. So this is point 2, 0, 4, 0, and 8 is 0. So a can be either 2, 4, or 8. So y is 0. Okay, those are all possible answers. Let's go to the next one. The function f is defined above. What is the value of f of minus 2? So that's the value of y when x equals minus 2. So f of minus 2 equals 2 times minus 2 minus 11. That's equal to 2 times minus 2 is minus 4 minus 11. That's equal to minus 15. So f of minus 2 equals minus 15. And that's equal to a coordinate of, not that we need it, just so you know, minus 2, minus 15. Because when x is minus 2, y is minus 15. They could have asked like, just an example here. Given this equation, f of x equals, I don't know, 16. Just find the value of x that makes y equal 16, right? So if they put this, what's the value of x? Okay, so just substitute f of x for 16. So 16 equals 2x minus 11. So we add 11 on both sides. 2x equals 16 plus 11. So 2x equals 27, dividing by 2. So x equals 27 divided by 2. So this will be coordinate 27 divided by 2, comma, 16. Easy. Good thing to know too how to differentiate what they're asking, like if they're asking for the value of y or for the value of x. The function f is defined above. If the function g is defined by g of x equals f of x plus 5, what is the value of g of 3? So here we've got to understand what they're asking. It's a transformation, and it's only going to affect the y value. So we can just literally substitute this into here, and then we can find g of x, and then we can find g of 3 from there. So g of x equals f of x, which is x times x plus 5. And we don't need to forget this plus 5, otherwise we're not going to get the answer right. So g of 3 is the value of y when x equals 3. So that's equal to 3 times 3 plus 5. Again, just substituting x for 3 plus 5. So g of 3 equals 3 times 8 plus 5. That's equal to 8, 16, 24 plus 5. So g of 3 equals 29. So g of 3 equals 29, and that's coordinate 3, 29. See, if you didn't add this 5 right here, if you just plugged in into the original equation, you would have gotten, let's check it. You would have gotten 3 times 3 plus 5. So 3 times 8, so 24. So that wouldn't be right. So you would check letter C, but that's not right because we need the transformation to take place. So we got to substitute into the equation for g of x. Okay, 6. The equation above is graphed in the xy plane. If h and k are positive constants and h it's different from k, how many distinct x-intercepts does the graph have? Okay, so they want the number of different x-intercepts. So the same one counts as just one. So x-intercept, that is aka the solution or value of x when y equals 0. So y is got to be 0. So let's substitute it. 0 equals x minus h squared times x plus h times x plus k. So if you've done my intensive course, you know to not be afraid of letters. Letters are just numbers that have not been assigned yet, okay? So what value in this part right here? So what value is going to make this equal 0? So the whole equation is going to be equal 0 if only this term is equal 0, because everything's being multiplied. And if one term equals 0, and the whole thing equals 0, then 0 equals 0, and that means that's a value of x when y equals 0. So we know that we got the possibility of x minus h that can be 0. If that's 0, then the whole thing is 0. So x can be equal to adding h on both sides, x equals h. It's one of the x-intercepts, h, 0, okay? X plus h can be 0, and so x equals minus h. That's a different x-intercept, so minus h, 0, and x plus k can be 0 as well. So x equals minus k is another possibility. So this is minus k, 0. You see, you don't need to do that on the test. I'm just literally teaching you guys the best ways of always thinking about like theoretically what's happening on the graph. So we got 1, 2, 3 different x-intercepts. So 3, it's the right answer. Okay. And if you don't know this, we're gonna touch this subject in quadratic equations. Okay. But pretty much we're trying to find the value of x that makes y equals 0. So if x equals 8, let's just like show it here. So when x equals 8, for example, we don't care about this x or this x, because if this term is 0, then the whole thing is going to be 0. So let me show you what's happening. So substituting h, which we know is an x-intercept, for x in the whole equation is going to be h minus h squared times h plus h times h plus k. Okay, so 0 squared is 0 times 2h times h plus k. We don't care about any of this. I'm just trying to show you guys that we shouldn't care. So 0 times anything, it's going to be 0. So that's a value of x that makes y equals 0. So we're good. And it's true for all the other ones in the respective terms. Okay. 7. I think that's the last one. Yep, that's the last one. The function f has the property that for all x, 3 times f of x equals f of 3x. If f of 6 equals 12, what is the value of f of 2? So 3 times f of x equals f of 3x. So we know that this can be f of 3 times 2, right? Yeah, which is equal to 12. Okay, and we know that we can do the opposite as well. So 3 times x, or 3 times 2, is going to be equal to 3 f of x. So that's going to be equal to 3 f of 2. So just using this relationship here can help us very easily. So that's equal to 12. So f of 2, we just got to divide everything by 3. So f of 2, so we can cancel this out, right? Equals 12 divided by 3. So f of 2 equals 4. Interesting question. That's the first time I'm doing this question. And it could be a good question for the SAT, because I don't know if many people are going to notice how easy it is just to use this relationship to answer the question. But f of 2 equals 4. So 4 would be the answer, all right? And this would be coordinate 2, 4, just in case, all right? And that should be it for functions. See you in the next video. Let me know if you have any questions.